In 7.4, we're talking about parallel lines and proportional parts. The first theorem is the triangle proportionality theorem, and it says that if a line is parallel to one side of a triangle and intersects the two other sides, then it divides the sides into segments of proportional lengths. So here's our triangle ACD, and we have our parallel line BE parallel to the base or to the side. Then it divides these two sides are proportional to these two sides. So you can see here if BE is parallel to CD, then we can say AB over BC is equal to AE over ED, right? So ratio of these two sides is equal to the ratio of those two sides. So we can create that equation. And then we also have the converse of triangle proportionality theorem. And it says that if we have the proportions AE over EB is equal to CD over DB, then we can say that those two lines are parallel. So it goes both ways, right? And so we're going to use it to solve some problems here. So we have here in triangle PQR, the big triangle, ST is parallel to RQ. Okay, so we know that for sure. And then we have PT is 7.5, so I'm going to mark it here, 7.5. And then we have TQ is equal to 3. And then they give us SR is 2.5, so SR is 2.5. And then we don't know PS, so PS is going to be our X. All right. Well, we know from the triangle proportionality theorem, this is going to be a problem all video, but anyhow, that we can create an equation, right? We can create a proportion, so we can say x over 2.5, I'm sorry. So x over 2.5 is equal to 7.5 over 3. So 7.5 over 3. And then we're going to solve for x. So we're going to cross multiply. We get 3x is equal to, and then 75, let's see this, 75 times 2.5. So 18.75. 18.75. And then we're going to now divide that by 3. And we get x is equal to 6.25, and we're done. And then we can look at example 2, and this is one that uses the converse of triangle proportionality theorems, where we have in the triangle EH is equal to 3, HF is equal to 9, DG is 1/3 the length of GF. Okay. So we're saying GF, we don't know it, but let's say it's X. Then DG is 1/3 of GF. So DG is going to be X divided by 3. Right. So it's saying, are these two line segments parallel? Is DE parallel to GF? And we can use the converse triangle proportionality theorem to prove that. Because if this proportion holds, then we could say that the two line segments are parallel. Right? So let's go ahead and put that proportion together. It's going to be x over 3 divided by x is equal to 3 over 9. And then we're going to go ahead and cross multiply. So we're going to get 9x over 3 is equal to 3x. From there, I'm going to reduce, so I'll get 3x is equal to 3x. And yes, the equality holds, and so we can say that DE is parallel to GH, and put a box around it, like so. Okay. So in the next two problems here, you're going to use the triangle proportionality theorem to find one of the line segments. And then in this one here, you're going to be using the converse triangle proportionality theorem to find that if the two line segments are parallel.